so trig, we're in 2.11. So they're going to give you some problems that'll have a pretty big looking scary formula that looks like the things that we've graphed before with vertical displacements and all that kind of stuff. And then they're going to ask you an easy question and a long question. So the easy question they're going to ask you is to find something like f of 8. Okay? If they ask you to find f of 8, all you're going to need to do, if they write f of x equals blah, 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 all this stuff, when they ask you to find f of 8, all that means is to replace the x with an 8. So when they want f of 8, you just find where the x is, replace it with 8, and hit a bunch of calculator buttons. So if I do that, this should turn me out I will say 4.2981. If you got 4.9997, change your mode. If you got something other than that, then here's maybe some places that you could go wrong. When your calculator is, when you push the cosine button, you need to start yourself off with, it'll automatically start you with a set of parentheses. The finish of those parentheses could go there. Okay, if all you punch, let's change my mode back. Trying to anticipate if you got a wrong answer, what wrong answers might have had. It's easier to troubleshoot this with people in the room. One thing I'll generally discourage people from doing, I don't think you should need your calculator to go 8 minus 6. So if you punch this in with a bunch of like nested parentheses, when your screen looks like pi over 9 parentheses 8 minus 6, I'm not positive if your calculator is going to interpret this as that the 8 minus 6 might be with the 9 on the bottom, and that's not what you intend it to be. So if you did punch it this way with nested parentheses, meaning parentheses inside parentheses, and you got a weird answer, the way to fix that is to throw in a multiplication sign right there. If we go pi dividing 9 times 8 minus 6 with all these nested parentheses, that should fix your problem. Another way to fix your problem is don't just be lazy and use the calculator to do 8 minus 6. You don't need the calculator to do 8 minus 6 for you. When I punched mine, I did pi dividing 9 times, and I did 8 minus 6 in my mind to get the 2. I don't need a calculator and nested parentheses to do 8 minus 6 for me. So the more you use those nested parentheses, the more likely maybe you hit a button wrong and something weird happens. That's our first kind of a thing we're doing here. We'll erase that out of the way. Is the first question A in every question, they'll say f of something. You just put that something where the x is and punch it in. Second question they're going to ask you is going to be a much longer question. Okay, they're going to ask you where f of x equals 1.3. So your start is just as basic. Okay, this f of 8 question was, the basic start was replace the x with an 8 and just do the math. On this, they're going to want you to replace the f of x with a 1.3. We're going to put 1.3 in this one. 1.3 equals 2 plus 3 cosine pi over 9 parentheses x minus 6, big giant thing. And our goal here is solve for x. And that's obviously going to take us some work. Okay, there's a lot of numbers in the way of that x. So you just have to kind of go like an onion, peel it a layer at a time, work from your outside in. So I want to get rid of first this add 2. So the first thing I'm going to do is subtract 2. If I subtract 2, I'm looking at negative 0.7. Then I'm going to divide 3. When I divide 3, now I've got that on the other side. Then what eliminates cosine is inverse cosine. Inverse cosine, I'm going to put a box around this, and we're going to come back and have a conversation about inverse cosine in a minute. But we do inverse cosine to get rid of cosine. To get rid of a fraction that's multiplying, we'll have to divide that fraction, which is going to flip it. So we're going to multiply by 9 over pi. And then to get rid of the minus 6, we're going to have to add 6. Now here's another issue beyond just that was a lot of opposites to do, but that was manageable. That's just algebra stuff. With one trig idea, the opposite of cosine was inverse cosine, but it's just algebra opposites like we've been doing for a long time together. What's different about this is that yesterday we learned that inverse cosine doesn't just have one answer. The calculator can give you one answer called the principal value, but there's not just the one answer the calculator gives you, there's an infinite amount of answers. What this homework is going to do is ask us, I believe, for 3 when we get going here. But what we're going to have to start off doing is get ourselves a single answer. So I'll sit down and just make this a little more comfortable to write. Make sure we're in radian mode, which we are from a minute ago still. We're going to go inverse cosine, negative 0.7, dividing 3, and I'm hoping to show up a 1.806. 1.806 is going to show up. That's one possible answer for this box. Okay, for us to finish this problem in a minute, I'll need to take that answer I just got, times the upside down fraction, add 6, and see where we stand at that point. But I'm not going to do that yet. Okay, but 1.806 is one possible value for the inverse cosine part of this process. But what we learned yesterday is that inverse cosine has an endless amount of answers. So we need to look to our general formulas from yesterday. So we have a general formula notes paper from yesterday, the 210 notes, that says for cosine, it's not just the positive answer we keep, but it's plus or minus, whatever the calculators say. You have a general formula in your notes for cosine radians that looks like that. Plus or minus, whatever the calculator said, plus 2 pi k. Which means this is a fine answer. The negative version of that is a fine answer. Just as fine of an answer would be the negative version plus 2 pi. Just as fine of an answer would be the positive version plus 2 pi. And we could build this list endlessly. I'll usually start off building a list of 4. Like I said, the ultimate goal of the book for us is to have 3 answers. So I'm not going to just start with 3 and hope they all 3 work. I'm going to go at least with 4 and hope that 3 of them work. I'd rather have an extra thing I don't need than be short and end up having to backtrack later. That would be more of a drag. Okay, so what these all are, all of these numbers in this list, these are all possible values that could fill this box with truth. Okay? The calculator has told us this is a true answer. 1.806, calculator says, is a win. But our knowledge from yesterday tells us it's not just about that one answer. We can take the negative version, and we could add 2 pi a bunch of times if we wanted to. And we could have made this list as long as we wanted. I did 4, I could have done 100. I stopped with 4 for now and hope that that's enough. What we now need to do with each of these answers is what I said we were going to do a second ago with the 1.806. 1.806 is only filling this part of the answer. Times this upside down fraction, add 6 has to happen. So the 1.806 is still showing on my screen. So I'm just going to do that one, times 9, divide pi, divide pi, add 6, and I'm hoping for a positive answer. And I get one. 11.17 is a positive answer. So I've got 1 win. I need 3 wins. What I'm after is the lowest 3. So before I work bigger, I'm going to work smaller. I'm going to try this one. This is a little smaller, but that might stay positive for us, so I'll see if it does. I'll go negative 1.806 times the 9, dividing the pi, adding the 6. I put negative 1.06 here, times the upside down fraction, plus 6. And that shows me a 0.83. That's still positive, so there's a win. Is it possible we could squeeze in another positive? Yeah, maybe. Is it likely? No, you're not likely to squeeze in something that's still positive that's under 0.83. So then I'll move up to this one. I'm going to use my second entry thing to just make a small change and use my insert key to turn this into, in parentheses, this cluster. I'm going to go in parentheses, negative 1.806 plus 2 pi. So this parentheses group fills that box, times 9 over pi, add 6. And that shows me 18.83. And that's probably our first 3 positives. The only thing we have left to do is verify for sure that we couldn't squeeze another one in. And here's a trick that we can use to verify that. Okay. Notice that the decimals on these are the same matching decimals. That should always happen for alternating answers. This is in a different family. We looked at that yesterday with our graphs, like the beginning of a hump can lead you to a beginning of a hump, can lead you to a beginning of a hump, but like the backs of the humps are like sort of unrelated to those. Okay. So every other answer kind of is in a family. The 0.83 should be in the same family as the 18.83. Their decimals will have to match. If you do any of these problems tonight and the alternating answers, first and third, don't have the same matching decimals, you made a mistake. Okay. They are also different by 18. If we subtract these, they're spread by 18. The alternating answers have to spread by 18. If this number's a 9, whatever this number is in this slot, double it. 18 has to be the gap between alternating answers. So from this back to this has to be a difference of 18. This mystery answer that probably isn't positive would be connected to this one in an alternating fashion. And they'd also have to be 18 apart. If this is an 11 and you try to backtrack 18, that's in the negative zone. So that is, as we expected, a worthless negative answer. We want these 3 to be our answers. But if this had been like 30, okay, from 30, we could have backtracked 18. And then we could wiggle our way back there. So take a small slide to my left. So instead of producing an 11.17, let's say I got something like 30.24. And my next one is 32.79 or something. If the problem had a pi over 10, pi over 5, the original setup, the pi fraction has a 5. That would tell me that I should get a span of 10 on these answers. So if back here I had a 22.79, I'd feel good about that because the matching 79s and those have a span of 10. I'd feel like I have some accurate information. But I wouldn't feel like I had the first 3 because this could backtrack 10 to that one, but this should be able to backtrack 10 to a friend. And that's not in the smallest 3 list. And then I'd look at this and think, could I backtrack again? Yeah, I could. 22 could backtrack to 12. And that's too big too. Do I have the lowest 3? Still probably no. Those are pretty big. And we're only doing a span of 10, right? So this 20 should lead you back to 10 less is a 10. So that was too big. And then this 12 could lead you back to a 2. That's too big. And then this 10 could lead you back to a 0.24, and that was too big. But from the 2, you can't squeeze in another one. That's as small as we can go. If we're going to skip back by 10s, those are the first 3. So if you have answers where you look like you have an agreement, like, hey, the 9 led me to spans of 18, you can use that trick to build answers at the answer level. You don't have to sit here and build all day at the general formula like yesterday answer. If you were here, I'd ask for questions, but you're not, so I guess you just have to rewind if you felt like you missed something. I'm going to trade this for a sign question, and I'll just do the same thing, because there's one minor difference if I do a sign question. I just erased a little bit of something that I shouldn't have erased, which was the plus 6. So if I go back to the top and say, okay, I changed my mind, it's sine, not cosine. The first thing we would do is just go back to the calculator. I'm going to just use my second entry thing to get back a little ways. Oh, 1, 2, 4. There you go. Loop it around. There you are. So I would do a 2 plus a 3, but sine. The calculator starts you with parentheses, pi dividing 9 for sure, and then I'm going to go times 2. That's just what I'm doing. I refuse to do 8 minus 6 in nested parentheses. And I'm saying 3.93 is what I'd be shooting for if I'm doing a sign version of that question. If I go to do the other version of that question of when is f of x equal to 1.3, I would just put the 1.3 in the same spot. I would do all the same opposites. It would have all the same appearance. It would only just be a signed thing. But sine is going to give us a different answer for our list. Inverse sine, negative 0.7 divides 3. Calculator says negative 0.235. Then I erased this general. For a minute ago, I had this for cosine, and I erased it, and I should have, because sine's general formula is x plus 2 pi k, and it is pi minus x plus 2 pi k. So when the calculator just showed me a negative 0.235, this is telling me that pi minus that, and the old minus minus makes plus is alive and well, pi plus that 0.235 is just as good of an answer. Calculator can give me a number. Pi minus what the calculator gave me, those are both valid. There's 2 possibles that could fill that box. Then both of these could have 2 pi added onto them. The negative 0.235 could add 2 pi. This could add 2 more pi. I already had 1 pi, so now I'm up to 3 pi plus a 0.235. And I'm going to list 4. I don't usually list more than 4. Okay? But if I wanted a 5th, we're back to the idea of yesterday of alternating. Answer 1 led me to answer 3 by adding 2 pi. Answer 3 could lead me to answer 5 if I just stack on another 2 pi to get 4 pi. If I wanted an option 7, option 5 could get me option 7 if I stack on another 2 pi, and I'm up to 6 pi. But we don't need that. If I want answer 6, it would rely back on answer 4, which would rely back on answer 2. And what I'd have to do is take this and stack on another 2 pi and get up. Well, this was answer 4. Sorry, answer 4 didn't exist. Answer 2 led us to answer 4 by stacking on 2 more pi. If I stacked on 2 more pi, I'd get answer 6. But I don't need 7 answers. Okay? My ultimate goal is get 3 positive answers. Don't throw this away. This is negative. That's okay. A negative temporary answer that's going to just fill this box may be fine in the long run. Because remember, we're going to add 6. And adding 6 might overcome that negativity, and it probably will. Okay? But each of these answers in this list, it's not a final answer. It's just an answer for this box. So we need to do each of these now, times our fraction, add 6. Key thing on this, as you solve, make sure your fraction gets flipped upside down. That's why I keep referring to that as the upside down fraction. The way the fraction looks in the problem, it's always going to be flipped by the time you're in your answer point. Okay, but I'm going to grab, well, I'll just do this one first because it's on my screen. So the one that's on my screen, times 9 dividing pi, add 6. That shows up 5.32. So that's a keeper. And it's also fortunately pretty low, because again, like I said, we want the lowest 3 positives, so 5's pretty low. I feel good about that. We're probably not going to sneak something under the 5. Possible, but not likely. So then I move on to this one. I'll go in parentheses, pi plus 0.235, wrap up those parentheses. This thing is in the value of the box, times the 9, dividing the pi, adding the 6. And that is 15.67. These have completely disagreeing decimal places, and they should. Those are generally just unrelated. This third answer should end with a 0.32. If this third answer doesn't end with a 0.32, we messed it up, and we'll need to retread the whole thing. But this third answer, I'll put this wrapped up in parentheses. So I'm going to use my second entry mode to just change my parentheses to be a negative 0.235 plus 2 pi, and I'm getting, it's actually a 3.3, wasn't it? I rounded funny a second ago. Whoopsies. That should have been a 33 on my rounding. So this is going to be another 33, but this is 23.33. And then let's use that trick from a second ago. We scan for this number, 9, double it is 18. The difference from this to its matching 0.33 friend should be 18, and it is. And then you ask yourself, could we squeeze another one in? And that answer is no, but it was close. Okay, we would try to focus, this third one is joined to the first one. So this is the one that would lead us to maybe a mystery friend, if we could backtrack 18. But it's only 15. That was a close call. If this were a 19, we would have backtracked. We'd have dropped this one and backtracked 18. But you can't backtrack 18. That's just the way that is. That's our lesson. That's our chapter. The homework on this is 56. It goes from 1 to 10. There is a way that we can use our calculator and graphing and a thing called tracing and zooming and stuff to make these answers agree. But I think I'd much rather do that in person than on a video, because on a video it's hard to interact with, wait, what button do I push? Did I push the wrong button? Here, fix my screen. I can't do that, so I'm going to just skip the graph thing. But remind me when we're in person if I forget. There is a way we can use the calculator and some interesting little features called zooming and tracing that we can verify any of these answers with the calculator. That's it. See you soon.